today is Joe Kuemerle. Joe, how you doing?
Good. How are you, Dave?
I'm doing great. Did you enjoy the conference?
It was awesome.
Before you get started, would you do me a favor and stand up for a second? I want people to see that you're wearing a kilt.
I am.
What's up with a kilt?
It was originally a Halloween costume for my wife, but I found that if I wear it to conferences, I get people to talk to me. So I can go out and actually make new friends very easily because they walk up and say, "Hey, you're the kilt guy."
That guy. You're that guy.
I'm that guy.
All right. Well, you're not just a kilt guy. You also have some tactical chops, right?
I like to think so.
One thing you know a lot about, I think, is we were talking about earlier about what was it?
The reverse engineering.
Reverse engineering, right? So reverse engineering, I always think of it as decompiling and getting back to like in .NET code, viewing the source code from the compiled code. Is that a fair definition of it, or is there more to it?
In the .NET world, that's pretty accurate. It's mostly what reverse engineering is taking something opaque, a binary of some kind, and running transformations on it to try and find out how it's actually working. Whether it's something you do in .NET with decompiler tools, and there are a number of them out there, that take the IL code, run it through a series of algorithms, and try and reconstruct an approximation of what the original source code is.
Okay.
Similar things, you do similar things in Java. There are decompilers there as well, because with both .NET and Java, there's a lot of metadata in those assemblies that are great, because as managed code developers, it makes it easy for us to consume other people's libraries, see what's going on.
Okay.
But it gives a lot of ammunition for a decompiler to use.
Okay, and you said we use the word ammunition because this is a threat.
It definitely exposes you in ways that a lot of developers don't think of. We think of, okay, we're going to build this code, it's going to compile it, and we're going to send off this exe or DLL or this jar or this APK, and that's it. It's a black box.
But it's not.
Well, to a lot of users it is,
Okay.
but to someone who just spends even a little bit of time figuring out how some of these decompiler tools work, your source code is laid out for them essentially. And anything that you've done in there, they can see.
So why should I be concerned about that as a developer?
If you follow good coding practices and good security tactics, you shouldn't be too concerned about it necessarily.
Okay.
But if you're doing something like you're encrypting some data and you don't want to pester the user for their encryption key or anything else, so you hard code an encryption key into your source, and you say no one will ever find it. It's trivial to find.
So reversing engineering would expose that encryption key just as text.
Yeah, it's text,
Potential hacker.
and anyone can do a simple search and find it. If you're talking back to web services, and you don't want the entire world talking to your web services, so you put some authentication on them. Say you even put basic authentication on your web service to stop someone just browsing along and accessing it, but you want your application to access it, and you embed the username and password in your binary, because your application needs to talk to your web service.
Right.
That's immediately and instantly visible to anyone who has a copy of your application.
Okay, so any bit of information that you wouldn't want a hacker to be able just to read in clear text, you should not have that compiled into your binary. Is that what I'm hearing here?
Yeah, you should not put it in your binary or any of your attached resources, anything like that. They're all very easy to get it out.
Isn't it possible for me to obfuscate my code so that it cannot be reverse engineered?
You can obfuscate your code. As with anything, there is nothing that's 100%. If I have a copy of your application and I'm sufficiently dedicated, I can decompile it, or I can at least disassemble it to IL, to intermediate language. It's not that hard to read. Because I can sit there and sift through it and find out things that you don't want me to find, especially if you're doing something like putting an encryption key in a string literal. That sticks out.
String literals stick out very well.
Sticks out like a sore thumb. Obfuscation can raise the bar a bit and make it more difficult for a casual attacker. If they see that your application's obfuscated, they may just give up and go somewhere else.
Okay.
But there are actually tools that plug into the newer decompilers that will undo some of the obfuscation that's injected in there by obfuscators. There's an open source project called D for Dot that's responsible for undoing a lot of that obfuscation.
So this becomes like an arms race, doesn't it, between the
Yeah,
obfuscation tool vendors and the hackers,
It
and the
absolutely
decompiler
is.
vendors, or
yeah.
maybe there are people selling decompilers? That's a commercial thing too, as well as just a hacker thing.
Right. No, there's a lot of valid use cases for decompilers. I just had to use one this week. My boss was out of town. He's the only one that has the binaries on his system for rebuilding the website, and there was a bug in it. So
You didn't have the source code.
I didn't have the source. Well, we had the source, but what we didn't have were the dependencies. There's COM dependencies and a bunch of other assemblies
I see.
that were needed. So what I did is I just went in, edited the IL because it was a real simple change, pushed a new build out onto the web server. When he comes back next week, he'll have to do a real build, but it got us out of a pinch.
Okay. So these tools exist for some legal and perfectly legitimate reasons.
Well, it was legal.
But like a lot of tools, they're being abused by
They can be,
for
yeah.
nefarious purposes.
Yeah.
Okay. So we saw one way that we could protect ourselves is just sensitive string literals are a big deal. Put those. What should we do with those? We put them in a config file somewhere.
Well, if they're in a config file on a client application, they're still visible.
Right.
Ideally, what you want is not to have any secrets embedded in your application. One of the ways I like to do this, if I need to encrypt data on a user's system, I'll use the built-in Windows for data protection API functionality, the DP API. There's .NET wrappers for it. You can really easily encrypt and decrypt data on a system, and it uses keys that are generated that are either only accessible to that user or only accessible to that machine. So you can actually encrypt data on a per user basis. This is another one I had to use in my day job. We have an application that's responsible for storing login credentials to third-party systems. So you're user A, we need to store your credentials. We want to synchronize those credentials up to a server so we have them for backup, but we don't want to be able to read them on the server.
Okay.
So we use DP API with your individual user key. It encrypts that data in a way that no one who's not you can't get it. It can get up to our server and to everyone else in the world. It's an opaque blob. You can't get it back.
Okay. What about we're talking about credentials? So is there a more secure way of storing credential information for like a web service call, for example?
Oh, for storing it for a web service call, that's a tricky one. I haven't had to do a lot of this in the real world, but what you can do is implement a private key, a public-private key system, so that you could potentially base the authentication credentials to your web service off of the signature of your binary, so that it would only work if someone is using the signature from an appropriately signed binary of yours to access that web service. And that way you're somewhat protected even if they decompile your application, change it, and re-sign it.
So recompiling it, it'll break it because
it'll break the signature. It'll have a completely different one, probably they'd have to sign with different certificates.
That sounds hard. Is that hard?
I don't think it would be that hard. I've done some proof of concept with it.
Okay.
It's more difficult than embedding a username and password into your application.
Yep.
But is it less difficult?
Well, what about what I usually do is I put that information in my config file, .NET's app config or web config, whatever.
Right.
And then I encrypt that. And I know you're saying, but there's an encryption key, but maybe I could use another methodology to.
Right. Well, what you could do is encrypt it and have if you ask the user to put in something to use as a base for your encryption key.
Okay.
If I'm a malicious person, I'm going to download your app, put in something, watch it in a debugger, see what that encryption key gets turned into, go to the config file, take that encrypted value, and decrypt it. And then I've got your credentials.
Oh, okay. All right.
Essentially, if I have your application
So I'm not being sufficiently cautious when I do this, take that approach.
It's a trade-off with security. It's always that risk versus reward.
Right.
You want to make it more difficult than somebody else, so that the attacker just goes after somebody else.
Right, or make it more expensive than the data itself that you
Right.
get worth.
Yeah, a lot of these.
Assuming everybody's motivated by money, which isn't true of all hackers.
Right. There are some that are motivated just by pride, and they'll come out and
Yeah.
they'll take it as a personal affront, and they will crack you because there's nothing you can do to stop it if someone's sufficiently dedicated and resourceful.
Yeah, right, that's fair. I mean, this is, you can spend an infinite amount of money and make it infinitely secure, but
Absolutely.
is that really worth your while?
Yeah.
Are there other things that I'm really thinking about, be worried about, if somebody gets access to reverse engineering my application?
Absolutely. Not just that they can get information out of your application, but that they can compromise your application, release a new version of it with that compromise in it, and start stealing people's information.
So they could just change, for example, the web servers that they're writing to,
They could
or
change
add
the
a
web
new
server.
web service that's
Right.
sending information up to that,
Yeah.
to their servers.
One of the things I demonstrate in my talk is I actually modify a WPF application. It has a login on it, and I show how to modify that block of code so that I inject my own code into it to capture the username and password that the user enters into the login, write it off to a text file on a network share. If I'm a disgruntled accounting clerk or something and I've got a little bit of developer knowledge and I do that, I make a new binary, I send it to the CEO, I said, hey, the IT department just sent me this, it fixes that bug you've been complaining about. He puts it on the system and runs it, and now I have the CEO's password.
I see. Interesting. What about just the algorithms? Are people really concerned about that? Is that as a trade secret, that I've got an executable that does some...
There are people that are concerned about the trade secrecy of their algorithms. And again, there is some value in obfuscating that as if it's a low value target, but if you have a dedicated competitor who really wants it and you ship a desktop version of your application or on some device that I have access to, be that a Windows desktop, a smartphone, iPhone, Android, Windows Phone, whatever, if it's on a device that I control, I can reverse engineer it. Your only protection, your only absolute protection for that is host it on a server that you control and make it, a web service or something.
So that makes sense. So put the UI on the smartphone or on the desktop, and the real proprietary stuff, keep that inside your firewall.
Right, because the whole thing is if someone has physical access to your application, it's theirs.
Just assume that they'll be able to eventually, somebody will be able to hack it eventually.
Yep.
Anything else?
Well, another interesting thing is that people don't think of smartphone applications as being something that can be reverse engineered. It's a similar issue with Silverlight. A lot of ASP.NET developers came into Silverlight and were just writing code like they normally do, not realizing that with Silverlight, that code is essentially running on the user's system, and that they have control over it. They can grab that ZAP file and decompile it and look and see what's inside, including web service credentials and everything else. Same is true with especially Windows Phone 7, somewhat with Windows Phone 8, although they've got some encryption on them now that's going to make it more difficult. And Android applications, the APK format can be very easily reversed back to a standard jar, a Java container file, which has all of that metadata back in it, and you can decompile that jar and grab information out of it. There are a lot of smartphone apps out there where developers aren't being careful about using cryptography and about storing credentials inside of their packages that's getting out into the wild.
Interesting. Okay. Yeah, smartphones open up a whole can of worms, and a lot of worms.
Right, and it's essentially a little computer that you're carrying around.
Yep, and it's obviously vulnerable to being lost, which is a huge security risk right there.
That's true.
Anything else?
One of the major ways of preventing or doing your best to prevent reverse engineering is to actually sign your code when you ship it.
Okay.
It won't stop someone from taking it apart, but it can stop them from putting out a version, a modified version that's essentially indistinguishable from your own. If
Okay.
you use a code signing certificate, they can't alter it without breaking that signature, and they would then have to re-sign it with a completely different certificate. So it's a way of verifying that to your users that what they've got is what you actually intended for them to have.
Okay.
And that's a great defense against people running counterfeit versions of your software.
This is good. There's a lot of stuff to think about. It's a lot, I think, that a lot of people are not thinking. A lot of developers are not considering this at all.
Right.
It's just not on their radar. Is that
Absolutely.
Your
Oh
experience?
yeah, when I give this talk, I get some really interesting looks at people in the audience with that.
they're like, I gotta go
That-
now,
yeah.
fix something.
Yeah, that light bulb goes on. And then sometimes the application's already out in the wild, so you've got to go and make some major changes
Mhm.
that if you'd started from the beginning thinking about some of this stuff, you wouldn't have even had in there in the first place.
Right. Now, are you blogging about this?
I am.
Where?
www.kuemerle.com is my blog.
Okay. You're also on Twitter, right?
I am on Twitter at JKUEMERLE.
Joe, thanks a lot.
Thanks, Dave. Thanks for doing all of this. One of the main reasons I love coming to these community conferences is because of the number of friends I've made in the technology space and how great it is to reconnect with everyone and to make new friends, which is why I wear the kilt.